Hello everyone. So, we will continue with the topic that metabolic heat and body temperature, how to control how the body temperature is controlled by human physiology and then by using the cloth, okay, to keep ourselves safe and comfortable. So, disturbance in stability of body temperature, as we have discussed, in winter it is a totally different physiology, and in summer the physiologies are totally different. Okay. So, in winter we have mentioned that the reduced temperature is controlled, that in winter our body tries to release the heat at a very high rate because of the temperature gradient, that our body temperature, body heat is say body temperature or skin temperature is say around say 34-35 degrees Celsius, and the outer temperature, the environmental temperature is much lower than the body temperature. So, our heat is released at very high rate, as we have discussed, by conduction, convection and radiation, and it is the net outward heat is much more than the heat which we our body generates by metabolic heat. So, there are two ways of stopping that, by body physiology, and if physiology fails, then by using the extra layer of clothing. Okay. So, the body physiology works at lower temperature when our body starts releasing the heat, okay, out to the environment. At that temperature our metabolic rate increases automatically. In winter, that is why in winter our metabolic rate is more. Okay. Then our constriction of blood vessel gets constricted, as we have mentioned. So, it releases less quantity of blood flow, it allows less blood flow. So, tries to retain the body heat, because blood flows out to the up to the skin, means it takes away the body heat and from there it comes out. Okay. So, heat is retained within the body by reducing the blood circulation. So, vasoconstriction is there, it reduces the body blood circulation up to the skin. Then, as we have mentioned, if it is insufficient, then our body starts another physiological phenomena which is known as shivering, by tensioning the muscles, and a person can be comfortable if we stop releasing the heat. The heat goes out if we actually retain the heat by wrapping the clothing. So, after if one layer of clothing is not enough, then we keep on increasing the layer till the body starts shivering. Is the extreme condition where the body physiology is not able to retain the body heat. Okay. So, a person stops shivering when he wears cloth which is due to the insulation provided by the clothing. Okay. Now, in summer what happens? Just almost opposite phenomena takes place. In addition to that, in summer the sweating process is activated. Okay. In sweating, through sweat directly releases the heat. So, if sweat comes out, it releases. So, that is why in summer our sweating activity starts. Okay. So, it starts from say when a temperature say around from 10 degrees Celsius to say it goes on increasing 30 degrees Celsius, then sweating activity starts. Okay. So, to control the increased body heat, so to release the increased body heat, so just opposite thing happens. What in case of in winter, the vasoconstriction was there. Here we need the extra blood flow to the skin. So, vasodilation is there. Okay. So, vascular system to enhance the heat flow up from the skin. So, vasodilation started. So, this picture shows very nice detailed about the what are the things happening here. So, our body always tries to keep the temperature in normal zone. So, if it is too hot, okay, so it affects the hypothalamus. Hypothalamus has got two types of sensation, it is a cold center and hot center. Okay. Hot center. So, if it is too hot, so hypothalamus sends signal to our body, and what happened, the vasodilation starts. Okay. And the capillary vasodilation is of the surface capillary starts the constrict vessel. So, it stops the constriction, it starts the dilation, that means extra blood flow takes place, then sweating increases, decrease in metabolic rate. So, as soon as along with the increase in sweating, vasodilation, so metabolic rate at summer at hot temperature it reduces, so that our body does not generate extra heat. Okay. Although already it has received heat. So, to reduce the to maintain that to reduce that level. So, it metabolic rate has reduced and hairs lie flat. So, that is the one phenomena, because here tensioning of hairs is not there. So, hair lies flat, and all this phenomena helps in cooling of body. So, that is the, and to bring it to normal temperature. In case of cold temperature, so that in cold center of hypothalamus, it sends signal where vasoconstriction is activated, that means blood flow is not there. Not there means blood flow is reduced, the sweating has decreased almost. We can see that in cold we do not sweat, because we do not need to release the heat, we have to actually we need to retain the heat. So, sweating is not activated. Increase in metabolic rate. So, to have to increase the heat, so metabolic rate tries to increase. Okay. So, here stands on the end. So, be due to the muscle toning, okay, it is tensioning, that it here gets straightened, and then shivering starts. Shivering, by shivering, as we have mentioned, that a body tries to get extra heat by mechanical vibration. Okay. So, this and this body heat increases to maintain the body heat. Okay. Now, if it is not enough to cool, so in hot, if it is not enough to cool, what happens? Then the cooling takes place by external process of evaporation. So, these are the all this phenomena, its activity by physiological activity, but if it fails, then the extra body heat in summer is taken away by the in the form of latent heat of evaporation, that we have discussed earlier. Similarly, if it this all these activities physiological activity fails to retain the body heat in cold, then what we have to do? We have to actually use extra layer of cloth to retain, to release, to actually restrict the release of body heat. So, this all these activities are actually done along with the clothing to maintain our body core temperature. Okay. So, this is the hypothalamus, okay, in the brain, which actually sense the cold and warm sensation. Okay. Now, the human body requires about 40 calorie per hour per square meter, okay, body area for the basic activities. That is the energy which is required for our basic activity. But the heat production rate increases, that metabolic heat, this is the basic metabolic heat is required. Okay. But this metabolic rate increases rapidly with the activity. If we keep changing our activity, our metabolic rate increases, okay, and that sometimes creates problem of overeating. So, these things we will just discuss, and produce heat has to be dissipated effectively. So, then our clothing has to act. So, not to retain the heat, but how to release the heat. Okay. So, at different activity we have different level of metabolic heat, and also with the activity, as our metabolic heat increases, our body core temperature also changes due to the activity. So, change in body core temperature with time at different level of activities are shown in this curve. So, just at rest our body core temperature remains same. So, we are resting, we are actually not doing anything, our basic activity we are generating this much heat, 40 calorie per hour per square meter of body, that typically it is around 80 to 90 calorie, because our human body area is around say 2 square meter. So, that type of body heat we generate, and that we get the body heat also we release that heat. So, our body temperature remains constant. But when we start walking, this metabolic heat increases, and the rate of heat generation is more than the rate of heat release. So, our body core temperature increases little bit, okay, initially, then after that it gets stabilized. So, with the time, but when a person do heavy activity, so at that heavy activity, so it generates more and more heat, huge quantity of heat, and our body core temperature increases. So, it goes beyond the, sometime it goes around say 39-40 degrees Celsius. So, that temperature it's that one has to actually maintain that, cool down the body heat, that core temperature by proper physiological activities. Okay. Now, try to see that for different activities what are the different level of heat generation, metabolic heat generation. So, at steady quiet conditions, quiet seated condition, so it is around say 55 to 65 watt per square meter. So, if we this is coming around say 85 to 90. Okay. So, that this is the seated quietly, okay, basic metabolic heat, that is when it sleeps. That, so, as the activity increases, so our body heat actually increases. So, our metabolic heat. So, if we walk at 3 kilometer per hour speed, we will generate almost double. Okay. So, that 110 to 120 watt per square meter. Okay. And similarly, for at higher speed we generate higher heat. So, and so a person, suppose he is playing basketball at high active, so the metabolic heat generation will be very high. So, that at different activity level, so our body heat generation is more and is changing. So, depending on that our body core temperature also changes. Okay. So, our function of our clothing is to maintain the body core temperature, to keep ourselves comfortable and safe. So, that we can only do by proper release of or evaporation of sweat. So, in case of heavy activity, the body temperature increases very rapidly, and the heat balancing is done by exchange of heat with the environment, mainly by radiation and to some extent by conduction. Conduction is very less, okay, mainly by radiation. Why conduction is less? Because the clothing or surrounding layer, the conductivity, thermal conductivity is very low. Okay. So, by and that is why this surrounding object like or environment by conduction is through is contact. So, this is actually least amount that we have seen earlier also. So, radiation is the process by which we can maintain our body core temperature. Due to lower thermal conductivity of air and most of the clothing material, the conductive heat flow is usually very low, okay, less importance. But when the fabric gets wet, the wet fabric has got very high thermal conductivity. So, in that condition, our clothing releases heat at very high rate. So, on the other hand, the thermal conductivity of a liquid medium like water is very high. Due to this, the insulation characteristics is almost lost when the garment is wet. So, then at wet condition we feel in even when the body temperature is very high. So, metabolic rate is high. If we wear a wet cloth, then we will feel cooler feeling, because of the garment lost its thermal insulation, and body heat, it releases body heat quickly. The release of excess metabolic heat happens through the secretion of sweat through the sweat gland, okay? And it from the sweat gland it comes out of the skin. The sweating rate sometime can be very high, it is a maximum up to 4 liters per hour, that at that rate one can actually release the sweat. The cooling of clothed human body in hot and humid environment, is achieved not by sweating, because the body heat it releases the sweat to release the body heat, but the cooling is not completed until and unless this sweat gets evaporated, because our body physiology, as we have discussed, it starts sending the releasing the sweat, but that may or may not be sufficient to keep our body cool. If it is not sufficient, then our that sweat has to, whatever sweat has been released, that sweat has to be evaporated, so that it gets the excess latent heat. Now, we can get feeling, when we wear one impermeable clothing in hot environment. What happens? The body physiology releases the heat with the help of sweating, but the sweating, the impermeable or non-absorbent cloth, it is not absorbing the sweat, and it is not also transmitting the sweat from inside microclimate to environment. What happens? The sweat simply start dripping. So, it is not able to take away the excess heat by evaporation. So, the person may not feel cooler, may not feel comfortable. Okay. So, in similar thing happens in hot and humid environment. In hot and humid environment, our body physiology releases the sweat, but as the humid environment is already saturated with water. So, that it does not take excess sweat, and that is why the person may not feel comfortable. Okay. So, we normally do not feel comfortable or cool, because the sweat cannot evaporate, it cannot get and takes away the latent heat okay, from our body, and the sweat simply drips. If it drips, that means it takes the heat from only by physiologically it through the sweat it takes out heat, but it may not be sufficient. In the case there is in case there is a little wind blowing. So, if in that case in hot and humid weather, if little wind blows, that means it takes away the humid air and then it enhances the evaporation and we feel comfortable even in the hot and humid clothing. We feel cool due to that why? Due to the release of latent heat, extra latent heat. So, in extremely hot and dry climate, so we will discuss this one. Before that, the wind blowing, if we blow the wind, that means that it takes away the heat, it takes away the heat in terms of the latent heat of evaporation. So, we can see there is an instrument it was developed here to see the microclimate temperature and humidity at different level of air velocity. So, here this is the chamber which actually it is partially filled with water and heater is there to maintain the heat temperature. This is thermostat control, that means this the heater will generate actually that the humidity. So, it actually that it gets evaporated. This the yellow color, this is the mimic skin, it actually simulates our human skin with micropores okay. And there is a gap, and this one it is a blue color, it is a fabric sample. So, in between the skin and this fabric we can control the gap. So, this place is known, this is actually simulating the microclimate. Microclimate means it is a place between our skin and the fabric. Okay. This is the place where we actually feel comfortable or not. Okay. Now, this microclimate, and above the this fabric there is a air duct which simulates the flow of air. Okay. So, we can change the flow of air by changing the fan speed. So, as the air blows, it will take away the excess humidity from here, and that our microclimate, we wanted to study the effect of microclimate on the at different flow velocity. Okay. And this is the picture. Okay. Now, here we can see as the with the time. So, at different time. So, this is initially the at the microclimate, the humidity increases. Okay. This is increase in humidity because the gradually humidity is accumulated from the skin to the microclimate. So, humidity increases here. Okay. And at this point, say here we switch on the fan. Okay. And speed increases at 4 different points, 1, this 2, 3, 4. At different point we actually change the fan speed. So, air blow rate. So, we try to study its effect on microclimate. So, immediately after starting the fan, the humidity of the microclimate reduces. That means, that due to the forced convection, it takes away the humidity, the moisture. So, that means that microclimate zone, the humidity reduces due to forced convection the water molecule, water particles is coming out from the fabric. So, our body gets little bit dry. Okay. So, that is why as we keep on increasing, the rate of reduction of humidity is more and more. Okay. So, these are the and similarly, if you see at certain temperature, here the temperature of the microclimate is constant when we do not change the fan speed, but if we change the fan speed, it gradually starts dropping. The microclimate temperature drops along with the drop in the humidity. So, this drop in temperature is due to that evaporation. Okay. So, that we have seen that there is a drop in temperature. So, initially increases, then it is again it drops. So, for different types of fabric it has been studied. So, different fabric they actually respond differently. Okay. So, these are the different activities. So, that which shows that the wind blowing also has got direct impact on that the temperature of our skin and the humidity of the skin. Okay. So, we will come back again here. So, in hot and humid condition, in case there is a little wind blown, that helps in evaporation of sweat even in hot and humid climate. So, that it evaporates and our body gets cooled down. So, it helps in our physiological activities. So, what happens then in extreme hot and dry climate? So, in extreme hot and dry climate, we sometimes we see that we feel that we do not sweat, because sweat actually gets evaporated as soon as sweat generates, and in extreme dry condition sweat as soon as it generates, it gets evaporated from the skin. So, it does not come out in the form of liquid without wetting our skin. It does not wet our skin. If it does not wet, that means we do not get the evaporative cooling. So, we have seen that in extreme summer, in dry summer, so we do not sweat. That actually if we do not sweat, then it is a threat basically, because the evaporative cooling helps in extra, it takes away extra heat from our body. So, body temperature remains it is maintained. So, by the heat supplied by the skin surface. So, it the insensible evaporation takes place, automatically it gets evaporated. Okay. So, no cooling effect is achieved and the body temperature rises stiffly. So, that we do not get the evaporative cooling. So, cooling extra cooling effect we do not get. So, stiffly our body, that means sometime what happened at very high and dry temperature, our sweat gland actually fails. So, sweating, we stop sweating, in that case the heat stroke takes place. So, if the body temperature, the sweating is actually activated around 30-32 degrees Celsius. So, that, but if it is say 45-46 degrees Celsius at high temperature, sometimes sweat gland may fails. So, we stop sweating. Okay. So, this sweat gland and then as its sweat gland stops, it fails, then so evaporating cooling does not take place. Now, coming to the phenomena of acclimatization. So, acclimatization, okay, is the evaporative cooling, where a person is acclimatized in a particular situation, particular environment. What does it mean? It means that the type of at certain that temperature, at that condition, the level of sweating what he is generating and level of heat that sweating evaporation is actually balanced. If it is not balanced, then the person will feel uncomfortable. like the evaporative cooling in a given climatic condition depends on the fact that whether a person gets used to that climate, okay, which is known as acclimatization. So, he has to be used to that environment. If a person comes from other place, okay, a cold place to suddenly in a warm place, so he will not be actually he is not used to that place. So, at higher temperature of the surrounding environment does not ensure that the sweat will always get evaporated. So, always it may not get evaporated. Okay. The sweat may start dripping for a person who is not used to that hot climate. That means, at that temperature he will start releasing more and more sweat. So, that release of heat, release of sweat and evaporation of sweat is not balanced. He is not used to that particular environment. So, the sweat produced and evaporation rate are not balanced. Okay. So, that person is not acclimatized in that particular environment. That means, the body heat transmission through evaporation becomes ineffective. So, it is actually a person who is in say acclimatized in cold zone, he suddenly he comes into some warm and humid place, he will for few days he will start feeling uncomfortable, he will start sweating, okay, because the sweating production and sweating evaporation is not balanced. So, on the other hand, if the same person get used to that same hot climate, that means body physiology will control the release of the sweat, rate of release of sweat, and the person whatever sweat he is releasing, he will start evaporating that sweat and he will feel cooler. So, this is the phenomena, and if during that time the clothing has to take active role in making the that person comfortable. Okay. So, sweat production and sweat evaporation is not balanced. So, he is for some after some time he will start, because he is acclimatized at that condition. Okay. And now the rate of sweating depends on the number of sweat glands. So, number of sweat glands are actually it is at different part of the body, the number of sweat glands are different. Okay. The rate of sweating depends on the number of participating sweating glands and output of each gland. That's this output is important. This output depends on the temperature. Okay. The evaporative heat loss is more effective if the sweat coming out from the active sweat glands covers uniformly, covers actually evenly in our body, but it is not that, because our body, different parts of the body, the concentration of sweat glands are different. Okay. If it is actually uniform, then it will be perfect. Okay. Evaporative, in some places we will find that we are sweating too much. So, we are sweating too much, that means at that point the sweating rate is more than the evaporative rate. So, sweat will start dripping, but on other places we do not sweat that much. So, that is how it is not actually distributed evenly. Okay. So, number of sweat glands per unit area is different at different parts of the body. Very high concentration in the front and back of the trunk here. So, at the trunk and back of hand, forearm, upper arm and forehead. So, in this forehead and there we will see that we start sweating, we sweat, because number of sweat glands are very high there. Okay. And the active this number of sweat glands are different at different parts of the body, and medium concentrations are there in arms, legs and cheeks. There we normally do not get sweat, and it is very low, it is of sole and palm. Here we normally do not sweat. Okay. So, depending on this sweat, this different concentration, we sweat at different. Okay. So, these are the different concentration of the sweat glands per square centimeter. Okay. These are the number of sweat glands. Here if you see upper back of hand, it is around say close to 375 per square centimeter. It is a number of sweat glands are very. So, these are the different types of, and minimum as at the cheek and temple. Okay. And depending on this type of number of sweat glands, we have to design our active clothing. So, active clothing, if we know the number of sweat gland at different portion of our body, we should be able to design our active clothing, which is actually supposed to absorb the sweats. This sweat absorption. So, where the that means at this zone upper back of the trunk. Okay. Here if we design our active sports clothing. So, we know the, so for active wear we know that this zone our sweating will be high. So, our type of fabric should be such that it enhance the evaporative cooling from that. Okay. And where it is low, we can actually eliminate that, we cannot, we need not take that much precaution. So, this is at a different zone is we can design our clothing accordingly, and this sweat gland is activated at different temperature, as we have discussed. As the temperature increases from say 10 to say 30 degrees Celsius. So, at during this increase the sweating, the sensation which physiological sensation which we receive, we get it gets enhanced. So, sweating is peak at say 35-36 degrees Celsius, and as the temperature goes on increasing, the sweating rate drops, and at very high temperature the sweat glands fail. So, these are the various physiological activities we have, neurophysiological activities we have discussed. So, in this segments we have discussed the different types of sensors available in our, sensors or receptors available in our skin to sense the different stimuli. The sensors are mechanical sensors and thermal sensors. Mechanical sensors are of different types: tactile sensors, the pain sensors, pressure sensors, vibration sensor that we have discussed. Also the thermal sensors we have discussed, that thermal sensors are basically two types. One is warm sensor, another is cold sensor. Warm sensor can be divided into two types. It is a normal warm and warm pain, hot pain sensor. Cold sensors are of two types, the normal cold and cold pain sensor, and knowledge of all these things are required to design our clothing for comfortable human being. So, we can design, if we have detailed knowledge of all these sensations or neurophysiological activity, we can design our clothing for proper comfort of our human being. Okay. So, we will end this neurophysiological sense phenomena of clothing comfort here, and in next segment we will start with our tactile sensation of clothing, where we will discuss different clothing structure, that means fabric structure, and how different measurement technique and different handle technique, handle measurement technique, this we will discuss. So, thank you.